Yes.
Yes. So we were counting number of tilings. So counting tilings. Using kind of recurrence ideas. Let me just say we were counting tilings. Yeah. So let's begin with the questions. Yes. So you tell me. You can tell me
So
in any
one
order.
question.
Yes.
So the one question was that there is a 5 into 4 rectangle,
Hmm.
and like there are five squares, sorry, 5 squares, and horizontally, and 4 squares vertically, like that.
Hmm.
So and there is like two joint squares, and you can use them either you can use them horizontally or vertically. And in how many ways can you fill?
Two joint squares. Okay. Okay. That's called a
And
domino.
so yes, sir. And this one, like, you have drawn it up, rotated,
Uh,
like it's
uh,
5 horizontally and 4 vertically.
so that's what it is, right? 5
No,
horizontal and
oh no, so sorry, I didn't said wrong. 5 vertical, 4 horizontal.
oh, but that will not matter. So that will not matter in the answer, right? And even
Yes, sir.
and so you are so the
A
dominoes,
domino.
yeah, they were like this.
Yes,
This
sir.
one, okay. I'll just and even you can flip it. Okay. So how many ways to tile? So what if do you know the answer?
No, sir, I can't do this.
Yeah, this is a very even I also don't know. It's a random question. Let's try to come up with a few tilings, right? Um, so like we have this tiling here, all vertical or sorry, all horizontal. So this is one of them. Yeah, this one can have many answers. Like it will be a very large number, I think. Yeah, probably I should have not given this question. No, so this will I don't think this will have an easy formula. Yeah, this. Like how many did you find? Did you try to list them? So I'll note them here. All horizontal. Then we have all vertical. Yeah, this will actually be seems like it will be a difficult question because there are simply lot too many configurations. Because it's 5 by 4, I thought that maybe we can do some casework. is 4. So if the first row, so there is case in which if the first row is what like this, yeah, if this is the first row, right? So can you tell me how many tilings are there for this?
So I don't understand the question.
The question. No, so the question is just like how many ways can you fill this 5x4 grid?
So like
No,
the
I mean,
question you just asked me just right now.
right. I'm saying that if suppose that I start my tiling by starting with this, like what I have done, meaning 2 horizontal dominoes in the first row. Okay. If I do this, then how many more options do I have to fill this thing?
There are many,
There are
multiple.
many, right? That is true. But there is a certain, but what I'm trying to say is that the problem reduces to a similar problem with smaller sides, right? Like say, if the original problem, let's say the answer is A5, 4, let's say, okay, because 5 rows and 4 columns, okay, let's say that's, then this breaks into cases like this is if first row has 2 horizontal dominoes. So then you see this is nothing but A 4, 4, 4, 4. Because if you do this for the first row, then you are left with a 4x4, right? You're left with a 4x4 array or board, 4x4 board, and you have to do the same problem. Do you see? What I'm trying to make you understand is the same problem we are now going to solve, but for 4x4, 4 rows and 4 columns instead of 5 rows and 4 columns. Now is it any more clear? Like there are still many, but the answer is again similar to the original question, but for a smaller case. Is that making sense? Like you see, the last day we had like the number of journeys, right? So we said that okay, if the last step was a step of length 2, then how many ways are there? Then it is like the same problem for 4 points, right? We still don't know the answer, but we know that it is the same problem for a smaller number of points or for a smaller case, smaller dimensions. Is it? Do you get this idea?
Yes, sir.
Right? It doesn't solve anything, but it may help us to set up an equation. So this is one case. What is the other case? Can you think of? Well, the other case can be if this is like this, if the first row is like this, right? So if the first corner is a domino, and then we have a vertical domino and another vertical domino, right? Like, see, what I'm trying to tell you is that there are 2 ways, right? You first put a horizontal one and you put another horizontal one. This is one way to start. Another way to start is you put a horizontal one and then you put a vertical one, right? When you put that vertical one, then you are forced to put another vertical one. Do you see this? This is the nice thing that's happening. If you put one vertical after the first horizontal, then you're forced to put another vertical Otherwise, how will you fill that? Okay. So do you see anything else that is forced? This is forced to again be a horizontal one.
Sir, couldn't it have been like taking the second and third, like vertical?
Second and third vertical meaning?
Sir, just a minute. Like suppose like this.
Uh, yes. No, no, no. That is right. That is right. Um, oh, right, right, right. Yeah, you are saying that even if I do this, then this one. So that's where I'm wrong. Well, I was trying to. Yeah, that is. Yeah, this problem is not so easy, or maybe not even a good problem. Either it is not good or it is very hard. Right. Let me just see. I don't. Maybe this is a hard question. Let me just check it out. If it's there. Uh, yeah, maybe it doesn't have an easy formula. So, ish, I gave you a bad question. Yeah, yeah, I know this is a hard problem, but I'll just show you. So you see, this is called domino tiling. Okay, can you see the screen? Uh, can you see the screen?
Yes, sir.
Yeah. So you see, oh, what I've given you is sort of this kind of question, right? Domino tiling. So do you see this picture, right? There now, in this case, there's an 8 by 8 square, okay? And you are tiling by these dominoes as we were trying to do. Like you see, this is 8 by 8 because this is 2, then this is 1, 2, 1, 2, and 1. So that's 6 plus 2, 8, right? So this is 8 by 8. And then there are several questions that one can ask, like when is tiling possible and whatnot. But counting the number of tilings, okay, so yeah, you can see this is a very, I don't think we can do this, get this formula, right? So the number of ways to cover M tile, this is huge formula, which maybe some point later you can study, okay? This is not a good question. Sorry, it's not a good question. I was thinking, but it's okay. I mean, we try something and it's good to realize. So you see, what I'm trying to tell you is that it doesn't break down easily into smaller cases. Like there are so many different kinds of cases. Okay. So yeah. So let us move to next question. So this is a hard problem for the future, you can think. So hard. Let's move to question two. Other questions are, I think, easy. I mean, like at our level.
So you had given a horizontal strip of 100 cells,
Mm-hmm.
and like this question has many subparts. So for the first subpart, there were a domino and a single square cell, and all of these cells are square, the 100 cells,
Mm-hmm.
and there's a domino and a single cell. So like how many ways can you fill with these two? types.
Right. Yeah. So this time we have the shape that we want to cover is simple, and we have two kinds of things using which we can cover. We can either tile using a domino, when you can use a combination of domino and single cells. So how many ways to tile? So any thoughts on this?
No, so I saw multiple ways.
Mm-hmm. Yeah, there are multiple ways, but did you get an answer? Any? No? Do you see any similarity of this question with the question that we are initially asked? You know, number of journeys using steps of length 2 and steps of length 1. No? This is like similar to that, right? The when you use it,
Yes, sir.
it's somewhat similar. Yeah. Now, if you're not able to make it precise, then why don't you try for small number of cells and see if you really get, um, what you expect. So, what should be the answer for this? Or maybe I'll ask you to fill this table. So if there is one cell, then there is one way. I think you know that. If there are two cells, then there are two ways, right? So if this is your thing, then either you can fill it with like this, or you can fill it like this, right? So that is easy. What about 3?
So 3.
Right? Okay. Now you can start building this table and maybe realizing, let's see, just try. Let's try and see. Sorry. Try for 4, try for 5, and see how they are growing.
So if the 100, it will be 100.
No, that why do you think so?
So because when it was 1, then number of ways came 1, 2, 2, 3, 3. So like,
Mm,
um,
okay, but do you think that is sufficient to say 100 will be 100? No. See why it is 3. Try to calculate for 4. No. I mean, you saw initially that it is similar to the journeys question. Somehow this taking a 2-step is like putting a domino. Taking a 1-step is like putting a 1 by 1 cell. There are many ways to do it, right? It's not going to be 100. For small case, it seems like that. Try for 4, 5. Yeah, then see. So this can be don't be very quick to conclude, okay, from the pattern, because then you can get wrong answers in exams also. And try to feel it. Try to feel what it's happening, or just calculate more terms. So for 4, you should be able to do, right? You keep it simple. Just calculate for 4 and see.
So I got confused too.
Okay. So what is confusing? Let me draw the picture for 4 by 4 and let us try to compute it. So you tell me. Like, see, I can put all ones. This is one way. Now you tell me one way.
All twos, two twos rather.
Right. 2 twos. Right.
Hmm.
So this is like 1 plus 1. Like last day you introduced this sort of way to write it. Right. This gave us some insight. Now you tell
1
me.
plus 2 plus 1.
Right.
1 plus 1 plus 2. 2 plus 2 plus 1.
So this seems to be all, right? 5.
Oh, so the sum of previous two things.
Yes. Yes. I mean, okay, that's what's happening from the pattern level. But can you give an explanation why it is sum of previous two? Like that is the uncomfortable, that's the place where we need to become good at. Why is it the sum of previous two? So if there are, maybe if I directly, if n cells is equal to, number of ways for n minus 1 cells plus can you explain why is it sum of previous two? See, I'll tell you one way. Last day, we did the exact problem, right? We said, okay, you have like the number n, and the question was about journeys and so on, taking steps of length 2 or length 1. But finally, we saw that the question was same as how many ways you can write n as using ones and twos, right? How many ways to get n using ones and twos? Do you agree? This is what the question was, like the journeys question. When you have a journey of length n total, and then you, like, as you take the steps, you just record the lengths, right? When you take a step of length 1, then you say you add a 1. If you take a step of length 2, you add a 2. But here also it is the same question. When you add a domino, you write 2. If you add a single cell, if you add a 1 by 1 cell, you add 1. So these are the same questions, and hence they should have the same answers, right? So, so we basically two questions which are different, but we are seeing a similarity between them, right? We are seeing how the counting, as far as counting is concerned, they are same. They grow in the same way. But still, I want you to explain me this directly. So let us try to understand this. It will be the same reasoning we did last day, but obviously here there are no journeys. So suppose there are n cells. Okay. So you have noticed the pattern that even if you directly calculate, you will see it will be 8. Okay. And here we are seeing a pattern that it is sum of previous two. But just seeing that pattern is not enough, right? Mathematically, that doesn't guarantee that it will be like that. We know as laymen, we know that it should be like that. But unless you give a reasoning that does not depend on these exact 5 and 6, yeah, you need to give a reasoning that works for any n, like 100, 100, and 102. That for filling of 102, it's enough to know number of ways to fill for 101 and number of ways to fill for 100, and you add them. You need to give an explanation that works for every number, right? So let's try to do that. So suppose that there are n cells. Okay. So this is the first cell, second cell, third cell. Yeah. So can you explain? Let's say that we are trying to tile this. So number of tilings. So how did we see last time that it was that this was the same as number of tilings for n minus 1 cells plus number of tilings for n minus 2 cells? How did we see that last time? Like it was just in terms of journeys? Well, we said, let us see the last step. Do you remember that, right? And it's very natural, right? Or you can even look at the first step, but when the last step is, so we look at the last step and we see what is the last step. If the last step is 1 or the last step is 2, that's it. Here you will say last step is either a 1 by 1 cell or last step is a domino, right? So last step is 1 by 1 cell. There's one possibility. And the other possibility, which is just a different case, and it's the only other case, obviously, is the last step or last tile. Maybe last tile is a domino. Are you seeing the similarity and following this?
Yes, sir.
right? See, it's okay. Like I can understand because this is like doing proofs. Okay, so it's a little new. Uh, Writing, being able to express it is so. Last problem in mathematics is being able to express what you, and this struggle is there throughout mathematical journey career. Okay, at our level also we are not able to express what we feel, and so we have to build some sophisticated language to say. Here it's sounding sophisticated to you. Tomorrow it will sound easy. So don't worry. Uh, try to do these reasonings. So just seeing the pattern is not enough. You have to find a way to explain that pattern. You can do it in your own way. But here this is how we did last time. It's similar. Okay. So last tile is 1 by 1 cell. Last tile is domino. So if the last tile is 1 by 1 cell, then do you agree that it is the same? Then do you agree that the problem now becomes of n minus 1 cells and tiling them using dominoes or 1 cells? Right, because now it's like we are left with n minus 1 cells and it's the same problem, right? So that many ways it will take. We don't know the answer. It doesn't tell us the answer, but it tells us how it relates to smaller case. Okay. Number of tilings for n minus 1 cells. And similarly, this I'll not say n minus 2. And these two you have to sum. Either it will be that or this. Right? And that is your answer for n. And so what you saw in the pattern that it is sum of previous two, I have now explained it. I've just put it in words. That's all. You know? So again, you know the answer will be Fibonacci series, right? It's 1, 2, 3, 5, 8, and then and goes on. Okay? So now you know that the nth term is the Fibonacci number, and you can quite rapidly also calculate. So the answer to our question would be F100, 100 Fibonacci number. If we start like this, in some books it may start with 1, 1. Don't blame me for that. It may start with F0 and so on, but it's more or less this is the answer. Okay. From our thing, calculations, from our convention, this is the answer. Okay. All right. It's a slightly new topic, but that's why I've given this question, which are this is like the same problem, but in a different disguise. Okay. Yeah. So let's meet on the. I'll just maybe end the meeting. Meet on the other side, and we'll try to look at the other questions and see if there are any new flavors in them or not. All right. Let's give it a try.
Okay, sir.
Yeah.